Okay, let's get started. Hi, everyone. This is Allie from HashiCorp, and thank you for joining today's webinar. We have Cody DeArkland as a technical marketer at HashiCorp, and today he's going to provide an overview of getting started with Kubernetes and Consul. We will then spend the last 15 minutes of the webinar dedicated to live Q&A. This webinar is recorded, and the recording will be made available after post-processing, usually within a day or two. It will be emailed out to all of you. Feel free to put questions in the question box as we go through the presentation, and we will answer them at Q&A towards the end. With that, we can go ahead and get started. Off to you, Cody.
Sounds good. Let me go ahead and fire up my camera here. All right, good morning, everybody. Again, this is going to be a really straightforward webinar around getting started with Kubernetes and Consul. What I really love about this type of webinar is that it really shows how easy it is to very quickly get started using Consul in a Kubernetes environment. Consul doesn't have a terribly challenging installation path anyways, but when you mix things like Helm and Kubernetes with Consul, you get this really quick start experience that lets you very quickly start realizing some of the cool benefits of Consul, things like service discovery, things like service mesh. So without too much delay, we'll just jump right in. So fun fact, this is my first webinar at HashiCorp since I joined. So most of you probably don't know me. I wanted to go ahead and just do a quick intro of myself. So my name is Cody DeArkland, again, technical marketing for Consul. What that means is that I'm here to build content and show you guys how you can actually consume Consul in kind of ways that solve problems for the enterprise. Right? We oftentimes will find content on the internet or on blogs or whatnot that shows you how to do things, but it's very rarely tuned for how you can actually consume this in kind of an enterprise environment. So that's kind of my charge, is building content for the enterprise. Best way to get a hold of me fastest is on Twitter. I'm on there all the time. So Cody DeArkland, you can drop me a message, and I tend to respond pretty quickly on there. And if you're ever curious what sort of nerdery I'm getting into, you can check out some of my code samples on GitHub, github.com/CodyD. So I included a picture of my kids because then if this webinar fails, you can't make fun of me too bad because my children are cute. So moving on. So here's what we're going to cover today. We're going to do a brief Consul overview. Again, this is meant to be purely a getting started on Kubernetes, but we'll do kind of a mile-high overview of what Consul is and kind of how it plays in the space. We'll do a little bit of a dive onto the service mesh functionality. Again, really focused on getting started. There's a ton of things that our service mesh does inside of Consul, and it would take 7 of these webinars to get through a depth of kind of advanced usage of that. So we're really going to focus on getting started and securing some basic applications. I'm going to show a couple of resources on HashiCorp's webpage around getting started. So some of our Learn guides, some of our documentation, as well as the actual Helm chart repository. We're going to talk about deploying Consul onto Microsoft Azure Kubernetes service cluster. So we'll actually deploy the Helm chart. And just full transparency, I actually have 2 clusters that we're going to be working with in this case, mostly because the Helm chart takes sometimes 3 or 4 minutes to get up and running. I don't want to waste your time sitting here watching kube control scroll on pod watches until it finishes loading. So I've got 2 set up, one that just has Consul installed, as well as the demo application, and then one that's empty. And then finally, we'll talk about how to secure those applications in Consul once we actually deploy them using Kubernetes and Consul Connect. So jumping in, applications in the data center were always fairly logical sometimes. And the joke there is that when I say logical, oftentimes I mean the way that applications were deployed typically fit standard patterns inside of the enterprise. I remember when I was an enterprise administrator getting requests from app teams saying, hey, I really want these IPs to be sequential, right? I want to be able to have .2, .3, .4, .5, and have that be my app servers, and then .10 and 11 be my web servers, because that's what I've done for all of my platforms. And services would scale in a fairly kind of manual fashion. I'm not saying they would scale quickly, but they would scale in a somewhat manual or somewhat predictable fashion. An app team would say, I want 5 web server or 5 app servers instead of 3. And they'd go and scale those, they'd initiate their ticket process, and the engine would roll. we had very well-defined kind of segments between environments, prod, dev, and QA. And the way that those environments communicated was somewhat standard. And we really focused on having security at the edge. So we assumed that once you were inside of the environment, everything was safe. So we concentrated the majority of our security on perimeter security. So how do we get into the environment? How do we stop bad actors from getting in? What we've seen over the past 3-4 years now is that as everything starts to move to dynamic, that those models somewhat break and they don't scale as well, and we start to run into interesting problems around how we understand how these services connect, when something like Kubernetes can have an autoscale policy that moves 3 pods into 5, and when somebody might deploy 4 more Kubernetes nodes, and that changes the entire scale of the applications that exist on them. So there's definitely a fundamental shift in how applications are deployed into an environment. I talked a little bit about that just now, and this spans across things beyond just Kubernetes, right? We see this in the virtual machine world. We see this in like the serverless space. These environments now are much more dynamic, and being able to automatically scale or dynamically scale your application is almost table stakes at this point. So you need platforms that enable you to actually adopt or adapt to that scale, right? When your web server scales up to 8 nodes during the holiday season because you have more web traffic coming in, you need to be able to react to that and have a platform that reacts to that for you, instead of saying, I've got to wait for the network team to add these 4 more servers to the load balancer pool, or I've got to have these firewall rules updated to allow these 4 more servers to come in, and then it's a 3 a.m. call on the weekend to a net admin to ask him to do that, or to get a manager approval to do that. It's just very different. It's a very different path to what was there around like I said 5 years ago. And those perimeters are blurring, right? Like the idea when as multi-cloud comes in and we look at how Kubernetes clusters existing between on-prem and multiple clouds, as well as VMs living in each of those environments, your perimeter lines get very blurred, and how we communicate between those environments and through those environments is a very different thing. So we dive into talking about Kubernetes. This is a good friend of mine, Keith, posted this quote from Brian at last KubeCon, and it's something that's it circles around quite a bit around the idea that Kubernetes isn't a product; it's a platform for building platforms. And what that means to me is that Kubernetes, at its core, solves a lot of traditional application deployment problems. We look at things like persistent volume claims, replica sets, how we scale applications, how we build a platform that is able to react without administrators being overly concerned with what it's doing. I don't want to frame that to say that Kubernetes is simple out of the box. It's a complex platform, because it is, in fact, a platform for building other platforms. So there's an inherent complexity that comes along with it. But there are a number of things that once you dive into that environment, you start eliminating from traditional platform management. When we look at that compared to Consul is a platform for simplifying application networking, right? We look at Consul as a platform that makes it easier to wire applications together and have applications react to change inside of an environment. And I know we're talking about Kubernetes here, but that's not always specifically a Kubernetes problem. Sometimes that's a multi-cloud problem, a problem across how we deal with VMs living in AWS, how we deal with VMs living in Azure, how we deal with remote and disparate data centers. These are all things that Consul solves in a really unique and interesting way. So I kind of alluded to this a little bit right now around what Consul actually does. At its core, there are kind of 3 verticals that Consul really focuses on: service registry and health monitoring. So what that means is the way when systems come online, they register services into Consul, and we're able to discover all of the nodes that exist within an individual service. You might have a web server that has 4 servers running or 4 Kubernetes pods running. These are able to register against Consul, and now Consul knows about them. And when you query Consul, you can see all of those nodes that are running that application. Beyond that, we take that to the next level with health monitoring. And health monitoring spans beyond just, hey, is the web server up? Is 200 responding? Or are we getting a 200 OK back from like a web server? This can be done via script checks as well, and having it run a script to say, hey, am I able to insert records into this database? Am I able to query the specific API path? What return am I getting? How do I deal with that logic? So our service registry and health monitoring is a very deep practice. There's a lot of capabilities there. We talk about network middleware automation, and this one's a little bit of a tricky phrase around it, but what it means is handling the dynamic changes that exist within a network between things like load balancers and firewalls, right? So we have an example out there around using Consul with F5, right? So if you have an F5 a load balancer doing east-west traffic inside of your environment, and you have that F5 pointed at your web servers for like your web front end, and all of a sudden you scale that web front end up to 10 servers instead of 4, we can actually have Consul send that data into F5 and have that F5 load balancer pool updated automatically to take advantage of those additional 6 servers, right? So it's a simple example, but there's a huge space for why that matters. There's a lot of time it takes to have, especially during like critical times where you're scaling out systems, to have load balancers and reflect those changes that are in Consul, and being able to automate that is a good thing. And what we're focusing on today specifically is the service mesh use case, right? So how do we take the services that live within Kubernetes as well as outside of Kubernetes? And that's kind of a unique thing about Consul, is our focus on being multi-cloud and multi-platform. But how do we take these and form a security-first isolated environment around them, right? So how do we say that anything that comes in needs to be explicitly allowed to communicate between services? And how do we manage that when things might coexist on existing servers, right? If you have an API and a web front end on the same server, which is typically bad practice, but it happens. How can we enforce that same type of security in that model? Typically in like traditional networking, doing IP-based security is a fairly straightforward thing. You know, can .2 talk to .3? Can .3 talk to .5? But how does that change when you want to make sure that web app 1 can only talk to database 1? We start to move to more of an identity-based model and what the system actually is that we're talking to, as opposed to what the address is of it. Because addresses can be, we can drop new systems on those addresses, and that opens up some interesting security vulnerabilities, especially since we now know that the majority of attacks happen from the inside via mistakes, via bad actors internally, via people who get past your perimeter environments. If there's one big thing I want you to take away from this webinar about what Consul is a networking solution for multi-cloud. What we're trying to do is we're taking a platform and we're building a networking space that spans between all of these clouds that you're deploying resources onto, and create a consistent way for you to deploy and manage applications and their connectivity between each other. This includes things like how we handle certificates and rotating those certificates, how we handle load balancing, all of that. Moving on. So when we look at Consul Enterprise, there's a few functionality that I really want to call out specifically. Things like namespaces. So namespaces are a functionality that was just added in Consul 1.7. That functionality allows us to somewhat segment greater the way services are registered into Consul. So you might have a namespace that exists for Cody's systems, and then John's systems and Jane's systems. That's a little bit of a bad example because those are separated by people. It's usually better to do like, this is the web team, this is the ordering team, and these different groups might register services that have the same name. In traditional Consul environments, if you drop all of those systems into the same environment, you're going to end up with some communication problems. Namespaces allow us to separate those out and have just a greater level of kind of enterprise scale around how we enable communication between those groups. You get automated backups and upgrades. So we have tools for dumping backups into things like S3 or Google. We also have the ability to automate upgrades. So when you look at things like how we move from Consul 1.6 to Consul 1.7, these are all things that automated upgrade and what we call autopilot actually enables. We have enhancements to read scalability in enterprise, and what that means is we have the ability to deploy what are called non-voting members, which means these are members that are pure read data, so how we serve data out instead of doing write intensive operations as well. It just increases scalability for how systems query against Consul. And beyond that, we can do things like network segmentation, where we say, this network is perimetered off from the rest, so we can isolate out the communication from a gossip traffic standpoint, which is how Consul replicates its data between. Redundancy zones, allowing communication between disparate environments and disparate clouds. And then advanced federation, which opens up some interesting doors around isolated network environments. So these are all reasons why moving to enterprise is important. And when you look at what the underlying message of what enterprise is all about enabling scale, right? And that's not just scale in the sense of how big do things get, but it's also scale in the sense of how do we manage things in an enterprise environment. When I have 10 teams leveraging Consul, how do I manage that? And Consul Enterprise enables that in a much cleaner way than trying to piece it together inside of just the pure open source model. The open source model is great for just getting started and using the platform, but when you want scale, you really need to look at enterprise functionality. So diving into the service mesh side of things, let's talk a little bit about some of the functionality that's built into the Consul service mesh. We talk a lot about service discovery. I hit on that pretty hard already, so I'm not going to spend too much time talking through what that actually means. Service segmentation, how do we enable systems to communicate, but as well as block unnecessary communication? How do we handle certificates, certificate-based security, things like MTLS between those services? And that's something that Consul Connect does really well inside of the service mesh. With some great observability capabilities, the ability to dump data out into things like Telegraph or StatsD, and then pull that into different dashboarding tools. So we have great observability stored in that space. Layer 7 traffic management is one that I really like. This was added somewhat recently. The ability to do things like traffic splitting, which enables cool things like A/B testing, right? Canary deployments, so on and so forth. Being able to control how traffic moves around within a mesh without having to drop additional load balancers in to control that. Consul enables that in a really cool way. Mesh gateways are really exciting. Mesh gateways allow us to connect kind of remote Consul clusters together. So if I have something in Azure, right, we're going to deploy onto Azure Kubernetes service today, and then I have something on premises, I can use mesh gateways to connect those two together and send traffic between those clusters. And that's kind of a big differentiator when we look at how we approach service mesh. A service mesh shouldn't just focus on one type of an environment. It shouldn't be specific to kind of one platform. Your service mesh should be something that spans between your entire cloud environment, whether it's on premises or cloud or 3 clouds or mixing all those with on-prem. So mesh gateways are kind of a core functionality of how we actually do that. And there's a lot of changes coming in this space to add a lot more interesting functionality for things like remote environments to that mesh gateway functionality. And finally, centralized configuration, being able to set kind of logical defaults and logical configurations for what your service mesh is able to do out of the box, so that when Cody onboards a new application into the service mesh, I'm not having to go through and reconfigure everything from the ground up. I'm adopting kind of the enterprise standards for central configuration, and I can tweak those as needed, but we have a good way of setting a solid baseline with using a central configuration. Like I said, today we're going to talk mostly about the service segmentation, because that's kind of a great place to get started when we initially deploy a Kubernetes cluster. There's a couple of resources I want to touch on real quick as we kind of dive into the meat of this. We have the Consul Helm chart. The Helm chart is used to deploy in a very easy way the Consul onto a Kubernetes cluster. So that's on github.com/HashiCorp/Consul Helm. We have the Helm chart reference, and I'm going to show our Consul IO page in just a second, so I'm not going to read this long URL. And then as well as the Consul Learn Guides for Kubernetes. These are all really great ways to very quickly start to understand how you can get this deployed onto a Kubernetes cluster of your own. For our environment, for the demonstration I'm going to do here in just a few moments, we're running this on Microsoft AKS, so Azure Kubernetes Service. So we've got, like I mentioned before, I've got a couple of clusters set up, just more so to save on time. Nothing special tweaked in those environments, just more set up so that we can do this very quickly and actually show you guys things instead of having to spend a lot of time waiting for things to install. If you're not using AKS and you still want to get started, there's a couple of other ways you can go. One of our developer advocates, or two of our developer advocates, I should say, Nick Jackson and Eric Veld, created a platform called Shipyard. Shipyard allows you to very quickly stand up Consul and Kubernetes environments locally on your system, and start to wire those together. They've got some really cool functionality around the mesh gateways in there. They've got a cool demo app set up that runs inside of that. It's a very easy way to get started with this. So I'd highly encourage you, if you just want to take this for a spin, check it out in a fun way. Definitely go check out Shipyard. When this deck goes out, the link is actually in here as well. And if you don't want to use the Shipyard path, you can use Kubernetes in Docker. I'm a huge fan of Kind. I use that in my previous role quite a bit. And you can actually run a Kubernetes cluster locally in Docker, which will let you simulate the same thing. I've got a demo application that I wrote that I'm going to use in this. You'll see that in a little bit, and I've included that in the deck as well. All right, so let's get hands-on and start taking a look around. So I mentioned that I was going to show you the Consul IO page. This is kind of what we consider our landing page for when people come to check out Consul and want to learn more about it. I'd highly recommend jumping in and taking a look at our Learn content, which you can see on this Learn link up top. And there's an entire section dedicated to running Consul on Kubernetes. So you can see a number of different paths you can take. I highly recommend the reference architecture section. When we start to move past kind of the basics on something like Minikube or Kind or Shipyard, we start to get into how we actually would really deploy this. We want to consider things like how we're handling certificates, how we're handling pod availability, stuff like that. Definitely read the reference architecture sections. There's a lot of good content in there around how to build this the right way to scale for an enterprise. Beyond that, we can jump into our docs. And I'm not going to go through our entire docs page on here or on this webinar, but there's a couple of sections that are really worth reading. Things in the Kubernetes section, obviously. So ways to integrate Consul DNS into Kubernetes, ways to get started with actual installation across the environments, how to actually do the Helm chart. There's a Helm chart reference in here as well for all of the ways to actually configure the Helm chart. We go right over here. You see configuration options. This will list out all of the different switches that are available in Consul to actually, or sorry, inside the Helm chart to actually manage the deployment. So ways to specify the image. So if you wanted to deploy 1.6 instead of 1.7, being able to specify that, data center name, things like enabling namespaces or ACLs out of the box, including your enterprise license. These are all things that can be configured in the Helm chart. And I'll show an actual relevant example of this in just a few moments. Beyond that, definitely spend some time in the service mesh section because that's what we're touching on today. So there's a lot of value in digging into what is actually available inside of that service mesh, or inside of the service mesh section. Things like when I talked about the L7 traffic management, the different capabilities we have for that are definitely a good read. The mesh gateways is definitely a good read. Understanding how we can allow communication between these environments is something that's very, very useful. Quick call out just to the Helm chart. There's not a lot in the actual Helm charts, the GitHub repository, because we keep a lot of that on the Consul IO page. But this is where you're going to pull down the Helm chart to actually interact inside of, or interact with the Helm chart inside of Consul. So now that I've given you kind of a mile-high overview of the website side of things, let's jump into the actual good stuff and work on some live demo. So I mentioned that I deployed out an AKS cluster for this. I wanted to do a quick call out for Terraform. I did deploy my clusters with Terraform. So it's very easy to get an AKS cluster using Terraform. You can see I've pulled out the Azure RM provider. I've specified a resource group. And then I've just simply defined out as code the infrastructure that I want to deploy for AKS. So I've named it AKS Consul. I've specified a Kubernetes version. I've given some basic node data. I've included and hidden my service principal information and given it a tag. And then I dump out the kube config for me. So this is what running this gets me an AKS cluster in about 15 minutes. That's a really easy way to repeatedly get this. So I can simply change the name and deploy it again and get additional clusters. I said that I would show a little bit more of a practical use around the actual Helm chart. This is the Helm chart directory. The values.yaml file will actually specify every configuration. What's really cool about the Helm chart is that it starts with some pretty sane defaults, right? We show you how to get started very quickly with some defaults that make a lot of sense for a basic environment. And then you can use something like an additional config file to sort of overlay changes onto that. And that's what I've done in this environment. So we can actually go in here and we can see all of those configurations that I showed on the Consul IO page with some high-level details around how to use each one of them. Moving on. If we take a look at the actual same defaults that I've set or the specific details I've set, I've enabled Consul Enterprise. I've specified my license key and how to actually configure those license keys. I've enabled namespaces. I've set how many systems that I want to actually run. This is because I was running in a much smaller environment before. I actually don't really need this anymore, but it's running here now, so there we are. I've turned on the UI, so I've said enable true, and I've told it to give me a load balancer IP. I've turned on sync catalog, so this will sync our catalog into Kubernetes. And then I've turned on connect for injection. And what connect inject actually does is enable the sidecars from a service mesh perspective for communication. So this will inject the sidecar into the pod, so then all that communication can take place over those proxies between the nodes. If you take a quick look at the application we're going to deploy, there's some insecure things in here like environment variables. This is because this is getting started, we plan on building off of this. So eventually this will be removed and we'll do some stuff with Vault in this down the road. So for this, it was just more of a basic, hey, how can I do this? So don't pay too much attention to the fact that it's not the right way to do it. That was intentional, so that we can kind of show a story later on about how to expand this. If you look at our annotations for some of our pods, you can see I've got connect inject true. What that tells Consul is, hey, when I see this annotation on a pod, go ahead and deploy the sidecar and enable it for connect communication. But then we also specify some service upstreams. And this is kind of the meat of the service mesh use case and how we start to wire these things together. In the case of my database pod, I want to enable communication between my database and my front end. So this upstream says, hey, database on 5432 is allowed to talk to the front end on port 80. We then take this the next step into the actual Consul UI to enable intentions to kind of allow this communications. This is more of the configuration from the proxy standpoint, but then the authorization and the actual access control happens inside of the UI or via command line or via API. In this example, we're going to do it via the UI though. Again, same thing applies for each one of these. I'm also allowing communication from our front end down to the API tier. So backing up, this actually allows communication from the database to itself and the front end, which is a little bit unnecessary actually. Front end down to the API tier. And that's our actual application that we're going to deploy. So if I switch back over into here, we can actually do a kube control, get nodes. We can see I've got 3 AKS nodes in my Kubernetes cluster. If I do a kube control, get pods all, we can see all the pods that are currently running. We're in the Helm chart directory right now, so what I'll do is I'll do a Helm install Consul, and that's the name that I'm giving it. I'll specify the current directory. I'll use the files flag, and I'll feed it that configuration YAML file that we talked about previously. And in a few moments, this will start to actually install. I can actually do a kube control, get pods all again, and we can see these items actually starting to create. I can do a watch against this, and we can actually watch it live start to come online. So these pods actually represent the agent nodes, whereas this represents the server, so the rest of these won't start until the actual server is ready. So we'll give just a couple seconds here and see if we make a change, and if it doesn't, we will move over to the other window. All right, in the interest of saving time, we will let this run in the background, and we'll actually switch over to our cluster that has all of this actually configured. So I'm going to export out a different kube config. We can see this is what an environment actually looks like fully configured with the application actually deployed. So I've gone through, I've deployed our application. I've got Consul running inside of this cluster. And if I do a kube control get service against that custom application namespace, oops, that's what I get for talking and typing at the same time, we can see our application has an external IP for it. We'll do a kube control get service so we can get the IP address for Consul. So we can see the Consul UI is right here. Switch back over to our UI, and we'll go into Consul. So this is Consul. This is completely deployed, and just to specifically call out, the only changes I've made are deploying that application and installing the Helm chart. So all of that takes place in a period of about 5 to 7 minutes tops. So in 5 to 7 minutes, you can have a configured and available Consul environment on Kubernetes. It's a pretty powerful thing. If you go and take a look at my intentions, I've got a default deny in place. So this deny will deny all service communication inside of the environment. If I go in and take a look at the nodes, we can see the different nodes that have registered. In this case, my Azure Kubernetes Service Cluster has registered to this environment, and I've got my actual server nodes that are available as well. We can see a number of health checks that are running on this environment. So I've got the sidecar proxies got health checks associated with it for ensuring that the service is actually running successfully on the back end. But I could define out additional health checks for the application. So for example, in the case of the database, I could say, is it listening on 5432? Is that communication available and able to be used? So going back to the earlier discussion around health checks, that's a capability we have as well. So let's go in and take a look at the application now. If I switch back over to here and grab the IP for the application. Our application here. We can see the application's fairly unhappy. Again, this is just a really simple sample application I threw together for this demo. You can see the API is not talking and the database is not talking, and we're getting a nice little error message on the bottom right that would imply that things are unhappy. Now we know we have our default deny in place, so we're not able to allow communication into the cluster, or communication is not enabled in the cluster right now. So let's go ahead and fix that. We go into intentions, we can do a create on the intentions here. And we're going to allow our front end to talk back to our API tier. Now, because I'm running enterprise, you'll see I have the source namespace and destination namespace. I talked about this earlier in the scope of how we can segment services based on namespaces inside of Consul. This becomes useful if Cody has an API running in his namespace, but maybe Jane has another API running in hers named exactly the same way. We can use this configuration to send traffic between those namespaces or to whatever namespace we want to define, or to allow communication between those namespaces. We would still want to allow those inside of the original Kubernetes YAML file. We want to specify that as the upstream, but this would allow the communication between those namespaces. We're not actually using any namespaces in this demo. That's kind of for a later video when we start to get into the more advanced use cases, not advanced, the more real world enterprise use cases outside of just regular getting started. So for now, we'll just use the default namespace. And we're going to do allow, and we're very quickly going to switch back to the application, and we're going to hope that we can watch it change live. There we go. So API connectivity is allowed now, and we can see that because it's gone green, and then on the bottom right, we have the pop-up that turned green as well. I can come up here and I can do API/health to actually see a status message back about the health being good. But we see our database connectivity is still unhappy. So let's go fix that as well. We'll go in and we'll create another intention for that, allowing our API tier to talk down to our database tier. Again, default namespace is allowed. We'll go allow, switch back quickly, and we're good. Now we can see all of our pretty logos. And what this ultimately allows is that now when I send a message via this tab, that message posts into a Postgres database on the back end. And we can see that the connectivity is also allowed because I can go to our API and I can go to the posts route, which will take me into effectively giving me a response back of all of the posts into the database. So in a very long-winded way, we've shown how we can deploy an application onto a Kubernetes cluster. Well, take one step back. We deployed Consul onto a Kubernetes cluster. We've deployed an application onto that same Kubernetes cluster. We've enabled that application for service mesh functionality using kind of the annotations within the Kubernetes YAML. And then we've gone through and we've started breaking up that communication via intentions inside of the UI. Now going a bit off plan, if we switch back to the other cluster, the one that I was working with previously, I'm willing to bet that it's actually finished its installation at this point. So it's still running. It takes sometimes up to 10 minutes to run, and this will hang out in crash loop until it actually finishes synchronizing. So it's taking a little bit of time. Unfortunately, I won't be able to pop into that one. So we'll move back to our previous cluster then. There we go. So everything's running securely. Now, finally, we'll go back in and we'll delete out these two intentions again, and we'll show how the connections go back to being blocked. So delete, oops, delete again. And if we go back to the main URL again, we will see in a few minutes this should fail out, or a few moments this should fail out and is no longer available. Just going to take a few moments. Oh, I deleted the wrong intention. Demo fail. We'll go back and recreate our default deny, which will block it. There we go. So our communication's back to being blocked and shut down completely. And that's it for the live demo. Again, this was meant to be a getting started path, so how we can actually get started with this. It was meant to be very basic, really 100, 200 level. As we move forward down initial webinars that Ali and I are working on, we'll get into things like using namespaces and like how we start to do true secure communication between things like bringing in Vault for a certificate authority, or securing our credentials with Vault inside of Consul and Kubernetes, or even bringing in other platforms into the mix. So again, really meant to be a basic 200 high-level overview of how to get started, and that's what we accomplished. So again, just to kind of underscore, only took us about 10 minutes to get to a place where we had this fully up and running. Again, the install and the other one's still running, but that should finish in a couple of minutes here. Yeah, so I think we are good to move on to the Q&A portion of this. So I'm just taking a look at my notes. I don't see any questions and answers popping in on the document, unless it just hasn't refreshed for some reason. Ali, oh, there are. Does layer 7 observability mean CASB type function? I'm unclear from a CASB function what that means. So layer 7 observability ties in more so to how we have visibility into the way traffic patterns route between the individual services in the platform. So for example, if I've set up traffic splitting between my API tier, right? I used the API or the Python API tier as an example in this. If I had a V2 of that Python API, and maybe I added additional routes, or maybe I had more verbose data coming back from it, we could actually use that layer 7 observability functionality. And really it's the regular observability and then the layer 7 observability, which are kind of two different things. But layer 7 observability relates back to seeing actual metrics and stats around how that traffic is splitting between those services. So if I've configured maybe a 50% split between the two, being able to see detailed metrics around how those are connecting. But then there's just the natural observability of the platform and the way Envoy as our proxy in this example communicates with backend services. So things like latency, things like hit count between services. These are all observability concepts that we can capture using the observability. So hopefully that answers the question. Feel free to pop in if not, and I can clarify some more. Other question was around Consul Connect and service discovery. So the service registered, when you deploy an application into Kubernetes specifically using Consul, it will, obviously Kubernetes has its own built-in service discovery, but if you enable catalog sync between Kubernetes and Consul, it'll actually synchronize the things that Kubernetes discovers into Consul as well. So you'll get effectively discovery in both of those. Now you can expand that and do a two-way synchronization where Consul or where Kubernetes will now get services as well from Consul, and you can do discovery from Kubernetes applications. So a good example of this is if I had in this example, I use Postgres living within the cluster. So I have my application deploy as a front end, a API tier, and then a database on the back end. If I move that database out of Kubernetes and I was running that on a virtual machine, like living inside of my environment, I could have that service discover in Consul, and then I could reference that discovery entry. So maybe database.consul.service or .service.consul. I could reference that in my Kubernetes application. It would hit the Kubernetes DNS, which would then get its information from Consul and return back the results of that. Into Kubernetes. So there's kind of two paths there. We can discover services in Consul from Kubernetes and reference them, or we can actually reference Consul services in Kubernetes using the kind of the two-way synchronization. So there's a lot of interesting options there around service discovery when it comes to Consul and Kubernetes. There are examples on how to register the service on the Consul.io page. I don't have a good demo set up right now to very quickly register a new service locally, like inside of this environment, mostly because this was all designed to work on Kubernetes directly. But there are definitely examples on Consul.io around service registration. A couple different paths to that, just from kind of feedback, so to speak. Services typically register as part of the systems that come up. So if I've maybe used like something like Ansible to automate the deployment of my front end, my web front end, I might include in that job registering the service locally against the local Consul agent running on that box, which ended up being either like a JSON file or an HCL file that has the details around what the service is and register it directly against that agent. We do this because then we allow the agent locally to manage its traffic, as opposed to having to send every query back up into the control plane, into like the main control plane for evaluation. So if you have multiple HCL files or JSON files stashed in your client configuration directory, it can load all of those and automatically register those services as part of deployment. As part of our approach to like kind of infrastructure as code and all things as code, right? We can actually have these service definitions stored with your application as code. So you'll always know what that actual definition is, and you're able to change that and modify that later and have it be kind of part of the source of truth for what that application is. So the next question was, can we see how the sidecar proxy is implemented in this example? And by default, the sidecar proxy is an Envoy proxy. So it's set to automatically inject as part of that intention that was deployed. So we can see that if we go back into, we can see, notice how these individual pods have three things associated with them. We can do a describe pod against database. Oh, oops. Sorry, missed our namespace there. And we actually parse through this and find the additional pod or the additional sidecar information for this pod. As far as beyond that, and as far as like the details of how that pod is actually registered, or it's not the sidecar is registered, I'd probably need a little more detail on the question in order to answer that well. But because it's a Kubernetes environment, the way Helm chart runs, this is just automatically injecting that sidecar. We can definitely run sidecars on things like Docker natively, in which case we're just using Envoy for the most part. We do have other sidecars that are coming up available, as well as on the virtual machine world, we have just the native proxy that's built into the agent. So there's a couple of options there. Good question on the next one, where are the TLS certificates? So in this example, we're using the built-in CA for Consul. So Consul is generating its own certificates and stashing them within the platform and sharing them between the nodes. We do have the ability to bring our own, bring your own certificates. So if we go back into the Consul.io page, there was a section on bringing your own certificates in here. I'm trying to remember where it was at. But there is the ability to bring your own certificates into Consul and have it actually register maybe against something like AWS Certificate Manager or Vault as a great example and a very common example. So in this case, though, like I said, we're using the built-in certificate authority inside of Consul to automatically generate those certificates. What version of Helm is supported? So version 3. So this is Helm. I believe I'm running Helm 3.1 locally, but it's been used always since back in Helm 2. So currently I'm using it with Helm 3, so I can not use Tiller for obvious reasons on that one. I think I just answered the next question, which was, were your services using MTLS managed by Consul CA? So yeah, in this case, we were using the automatic CA within Consul. So the MTLS encryption was set up from that. I believe that I'll have to double check on this next one. Is a sidecar injected via init containers CNI chaining? I believe that they are injected as init containers. I'm fairly confident that they are. But I will double check on this one and consult with Ali on how to get this answered in the best way. Consul open source absolutely supports the Kubernetes functionality. For a funny example, all of my prep work for this webinar was done on the open source version. I didn't actually enable the enterprise version until like about an hour and a half ago. So all of the functionality, with the exception of namespaces, was stuff that I tested without using the enterprise version. So you can absolutely download the Helm chart right now on a Kubernetes cluster and throw it in without any sort of major problems. You can absolutely deploy the Consul and Helm chart into in Minikube or a single node cluster. There's one big call out though on that, and I will switch into code example to show you what this is, because this is kind of hit a few people now. If I go in and I open up my config, just doesn't really matter which one, I'll just grab the config.yaml one. If you're going to run a single node, you're going to want to change this server and replicas down to 1 instead. Reason being, if you try to have that expecting 2 nodes, it's going to fail, right? Because there's only going to be a single node cluster. Same thing for replicas. It's not going to succeed. So you just want to make sure that you change server replicas down to 1 and bootstrap down to 1. And what that's telling Consul is, hey, only expect 1 node to come up to get started. The OpenShift the next question was OpenShift. Is there any documentation for installing an OpenShift 3.11 or 4x? We're actually discussing this right now. Currently, there's not any like dedicated directions for using Consul with OpenShift, but this is a conversation that's coming up right now. So stay tuned for more. So I can't demo, the next question was, can you demo how to configure L7 traffic router in a Kubernetes environment? I can't demo that right now, mostly because that was a planned demo for the next call, actually either the next call or one after that, around starting to manage traffic between these environments. If you were more so looking for specific options, like how that actually works, you can come in and actually see that in the L7 traffic section, where we actually cover some examples of how to set it up. So down here, if we pop in, we can see some of the different configurations. These are registered directly against Consul. So these are examples here, but we'll absolutely be doing a webinar specifically on using the L7 features, probably using like an ingress controller like Ambassador or something like that to handle getting into the cluster. But yeah, so stay tuned on that. As a Kubernetes noob, can you talk about Consul security differs from base Kubernetes security directly? So there's lots to unpack on this one. By default, so security is a multi-layer thing. By default in Kubernetes, there's no encryption between pods. First off, right? So pods communicate directly with one another based on how services are exposed or how the pods are deployed or how the deployments are done. So as an example, there's no encryption between those by default. Consul adds that layer on, given like the example I answered before around MTLS and the built-in CA, as well as bringing in external things like AWS CA. The intentions concept is different. That relates. The intentions concept is very comparable to like a firewalling or identity firewalling, where we're saying, hey, how do these servers talk to one another? Kubernetes treats that pod communication between each other within its environment in a fairly straightforward way. Consul is how we secure that communication between. Also, not on the security front, but back to the layer 7 stuff we were talking about previously, Kubernetes natively has no way to control flow of traffic between, in like an A/B scenario where you want to do not testing, like if you want to move services from one version to another without completely tearing it down, you can use Kubernetes to replace pods very easily. and Kubernetes will very logically cycle out of service in very elegant ways. But if you want to do like traffic shaping patterns, circuit breaking, service resolution stuff in that way, that's not available inside of Kubernetes by default. Again, the security one is a very deep chasm to get into. So if there's specific questions, I can answer those, but it's probably better to handle that one in a separate. Got about 8 minutes left, so I'm going to try to power through the rest of these. How deeply is Consul integrated with Azure? Does Consul support Azure and Microsoft Identity? There's more to answer on this one. There's a lot to talk about around Consul and Azure, so I'm going to stay away from this one a little bit. But what I will say is, out of the box, it does not support like Microsoft Identity built into the cluster. It does support, I wouldn't say Consul supports directly, but if you're deploying onto AKS, there's ways to bring in credentials from Microsoft into those AKS clusters. That's less of a functionality of Consul though, and more of a functionality of AKS and Azure in this case. You can absolutely run Consul natively on Azure today if you've stood up several machines, but there's a lot of stories around this that are coming up. If you look back at like our announcements from previous HashiConfs around HashiCorp Consul service on Azure, we're going to have a very native way to run Consul on Azure directly in a managed service. So all of this stuff that I just did around deploying like the Helm chart stuff, that's all handled automatically by deploying Consul in a managed fashion. So you can go watch the videos from HashiConf around HashiCorp Consul service, and that'll answer that. Does it come with a dashboard like Kali or Kali on Istio? No, so we don't have a dashboarding built in, and the reason for that is quite intentional. When we checked with our customers, we're very big on customer feedback. We're very big on kind of listening to what our customers tell us. We found that the majority of our customers had specific dashboarding platforms that they already wanted to work with, and that the idea of having like Kiali in this case, which Kiali is a very nice dashboard to look at, that solved the problem for like an initial demo or initial use, but they oftentimes had larger scale Grafana deployments or maybe like a Wavefront deployment from VMware or something like that. They had a bigger dashboarding platform or like a Datadog and Play or something like that, like these bigger dashboarding platforms that were more of an enterprise thing. And it didn't make sense for us to try and replicate a new dashboarding platform when the majority of our customer feedback was that they just wanted ways to get the metrics out into those dashboarding platforms. And we did that via like the stats export I talked about a little bit earlier around the observability configurations to move those configurations out to like Telegraph or StatsD or whatever, and be able to move them into like Prometheus to pull data out of. So it was an intentional choice. It's something that we talk a lot about around like what our observability story is. So totally open to feedback. We'd love to hear more. Absolutely. The next one, 17, can Consul connect services from separate Kubernetes clusters? Absolutely. It's one of the cooler use cases to see, actually, being able to stitch together multiple Kubernetes clusters as well as multiple environments. So imagine that you have something running in, you have an AKS cluster in Azure and a Kubernetes cluster running in VMware vSphere. We can absolutely stitch those environments together using service mesh. And that's when Consul truly shines, is when you start to look at Consul as a way to stitch these environments together. Like I talked earlier about the application networking. If you look at Consul as a platform for bringing these other platforms together and stitching that communication together, it becomes a really interesting story. So short answer, yes, absolutely. Multiple Kubernetes clusters, multiple types of Kubernetes clusters, and multiple platforms. Does Consul support circuit breaking? As of 1.7, Consul does have circuit breaking functionality. It's either 1.7 or it's coming in 1.8, but I believe it's in 1.7 for circuit breaking. Trying to find a leak 2 weeks ago at Kubernetes. I don't recall seeing anything about Kubernetes stopping support for Helm. I can look into that. If they do stop supporting Helm, we will have a different installation method, I'm sure. Typically, Kubernetes itself doesn't support Helm as much as Helm supports Kubernetes in that way, right? So if you look at Helm being one of the CNCF projects, it's not so much that Kubernetes was designed to use Helm, it's that Helm was written to use Kubernetes. So I'd be interested to read that article. So I'll dig around and see if I can find that and try to get something out about it. Is there an Azure demo? I'm assuming that was based on the earlier question around an Azure native environment, HashiCorp console service. Stay tuned. I will have there will be something very soon around an Azure demo on this. Does Consul rely on Ambassador? It doesn't rely on Ambassador. We tend to do a lot with Ambassador in the platform, but you can absolutely use other types of ingress or other ways to get into the cluster. Examples being like Nginx ingress, traffic, Kong, Ambassador. Like all of these will work against Consul. Obviously, like they all have their benefits, and it's the most well-rounded we've kind of worked with generally is like Ambassador a lot. Like it covers a lot of our use cases. So we do a lot with Ambassador, but it's not a reliance by any means. We have an existing Calico network policy based project. How can we use Consul? There's overlap. There's probably a lot more to unpack on this one around like what that network policy is actually doing and kind of the differences between the two approaches. One of those is a CNI based approach, right? How Calico handles policy directly from like a container networking perspective versus what Consul is doing as far as like stitching environments together. What I would say is when you look at like off the top of my head, your Calico networking policy gets interesting when you start to stitch in different environments, right? If you look at stitching in like multiple Kubernetes clusters spanned across multiple clouds, if you look at a Kubernetes cluster tied into virtual machines, how that plays out would be really interesting. But this one's a tough one to kind of answer on the fly without asking a bunch more questions around like what that network policy is doing today. I can see definitely spaces where there is overlap in the sense of like Calico saying service A can talk to service B from like a traditional kind of network firewall-y perspective. But there's certainly other things that Consul does that span beyond just the security use case as well. So did I get them all, Allie? I think I did. I think I'm ready to pass back to you.
Yes, perfect. Thank you again to everyone who submitted questions and to Cody for the great answers. I hope everyone enjoyed today's webinar and you all have a better understanding of getting started with Kubernetes and Consul. For more webinars, you can visit our website at hashicorp.com/events. Finally, as we mentioned at the beginning of this webinar, the webinar was recorded and we will make the recording, slides, and answers to the remaining Q&A available on our website after processing, which is typically within a day or two. We will also send an email to everyone who registered with the recording link. You can also keep an eye out on our social for the recording. Have a great day and goodbye, everyone.